Alrighty, welcome back. Today we're going to be looking at a logic puzzle, and the idea, well, this is the start of a series essentially, whereby I'm going to be looking at every single type of logic puzzle that I can find. That includes basically all possible variants of Sudoku and a bunch of other wild and interesting puzzles, like Minesweeper, One Up, and essentially a lot of stuff. Okay, a lot of stuff is coming. Okay, a lot of weird and wacky puzzles. I don't know if it's really possible to even finish this series. There's probably lots of different variants of Sudoku out there, probably far too many. But essentially, I want to try and complete as many different types of logic puzzles as I possibly can, in my lifetime, really. And this is kind of the start of that sort of completion, I guess. And today we're starting with the first sort of puzzle type, I guess, that I have, which is known as sort of a percent Sudoku. And it's called a percent Sudoku because, as you can see, when you look at this grid, there are these sort of, it's a Sudoku grid, but there's also a circle or two circles and a diagonal line like this, which if you were to remove the grid and the numbers, would obviously give you the percent symbol. So that's kind of the basis behind this Sudoku. I'm sure there's lots of Sudokus like this one with the rules that I'm about to read out. But yeah, this is the first type of logic puzzle that I'm going to be looking at. Not all the logic puzzles I'm going to look at will be Sudoku puzzles, and I won't necessarily go live to complete all of them, but I will try and go live to complete them, as many of them as I can, as I can. But yeah, without any further ado, let's get straight into this puzzle. So what do we have here? We have a percent Sudoku. So how this works is it's just the same as any typical Sudoku, first of all. So all classical Sudoku rules apply in the sense that in each column, the numbers 1 to 9 must appear exactly once. In each row, the numbers 1 to 9 must appear exactly once. And in each 3 by 3, the numbers 1 to 9 must appear exactly once. However, we have some additional rules. So we have a diagonal here. So there's obviously 9 numbers that can go in this sort of diagonal, or in these sort of 9 diagonal boxes. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and those numbers cannot repeat, which essentially just means that there can't be any repeated digits along that diagonal, which essentially just means that the numbers 1 to 9 appear exactly once also along that diagonal. Okay, so that's sort of an additional rule for this type of Sudoku. And also, the sort of boxes encoded by these two circles are these. So there's actually 8 boxes per circle, which I'm highlighting now. So each of the boxes which I've highlighted here are represented as being within or being touched by the circle. And each of the digits in these 8 boxes must be different, okay? Obviously, in Sudoku, we use the numbers 1 to 9. So there are 9 numbers, which means that one of those 9 numbers will not be used in the circle. And we're also told that the same set of 8 numbers is used along both circles. So for example, if the numbers being used in this circle were 2 up to 9, then it would also be the case that the numbers being used in this circle were 2 through 9. So there wouldn't be a 1 in any of the sort of boxes indicated by the circle if we were able to prove that the digits in these boxes were 2 through 9 and could not be 1. Okay, so those are the additional rules for percent Sudoku. Without any further ado, let's get straight into this. So the first thing we can do is just apply standard Sudoku rules. So if we look at this 3 by 3 here, and we look at specifically the digit 6, then you can see, by the way, do give this a try if you haven't already. Pause the video and try and solve it for yourself, and then I'll go through my solution pathway. So first things first, we can just use standard Sudoku rules. We can essentially note that those rows and the column already involve a 6, so the only place a 6 could lie in this 3 by 3 is here. And this also shows us that the 6 lies in the circle, as this box belongs to that sort of bottom right circle. So we know that there has to be a 6 in one of these 8 boxes up here as well. Obviously, some of those have already been ruled out. But we can kind of just we don't have to worry about the circle constraints yet. We can kind of just keep doing Sudoku, and we should be able to make some progress. So if we look at this top left box here, then when we consider the 6s, we note that there's only one box, this box, which could be a 6. So that gives us a 6 in the top left. And I think now what we can do, potentially, is look at the diagonal and use that constraint. Just trying to see, yeah. So essentially, we know that the numbers 1 to 9 each have to appear exactly once along that diagonal. So if I consider 6 and I consider where it might lie along the diagonal, I note first of all 6 can't be here because there's already a 6 in that column. In fact, it can't be in any of these 3 boxes because there's already a 6 in that 3 by 3. Similarly for these 3 boxes up here, because there's already 6 in that 3 by 3, and there can't be a 6 here because of the 6 in that column. And there also can't be a 6 here because we have discovered that there's a 6 here. So the only place a 6 can go in the diagonal is in this box here. Okay, so we've got that 6. Okay, and then let me see. Is there anything else we can do? Well, if we look at this box here, we already have a 6 in the top left circle, which means that these 2 boxes can't be 6 because we can't have repeats of the same digit in sort of any circle. as indicated by the new rules. Also in this column, we already have used a 6, so that can't be a 6. That can't be a 6 due to the row, and that can't be a 6 due to the column. So we've discovered that this, therefore, the middle cell there, therefore must be a 6. And then if we use Sudoku, we very easily see that this cell here has to be a 6 because none of these cells in this 3x3 can be 6 because of the fact that there's already 6s in those rows. So just like that, we've got all the 6s in the grid. So that's it for 6. And yeah, there we go. At this point, let's see, there should be... Yeah, so if we look at this sort of top left box here, and we consider the digit 4, then we note that essentially the only possibility, the only sort of cell that could contain a 4 is this box here, simply just because we already have 4s in, if I look at this box, there's already a 4 in that row, and essentially by Sudoku, the other boxes are ruled out because of the 4s in those columns. Okay, so there we go. That is that. Let me see. And if we look at the diagonal, we know that there can't be a 4 in any of these 3 cells, there's already a 4 in that 3x3, and there can't be a 4 in any of these 2 cells, there's already a 4 in that 3x3, there can't be a 4 here because there's already a 4 in that row, and there can't be a 4 here because we've already just discovered there's a 4 in that row. So the only place a 4 can go is in this cell here. At which point, let me see. Oh, and also for this 3x3 here, if we look at the 4s, you can sort of realize that this middle cell here has to be a 4 because none of, this cell can't be a 4 because of the 4 in the row, and the other ones can't be 4 because of the 4 in the columns. So that's that. And then if we use Sudoku on this bottom right 3x3, we get that the 4 has to be in this cell here. Okay, awesome. Yeah, and essentially now we know that none of these cells here can be 4. Although most of those are very obvious, but essentially just reminding you that the circle rule means that there can't be any repeated digits within either of the circles, okay? At this point, we can actually prove something which is going to be quite useful, which is that the digit 9 cannot be in any of these, it cannot be in any of the circles, essentially. So you can't have a 9 in any of these sort of boxes here, is what I'm trying to prove at this point, which therefore implies that the circles have to contain the digits 1 through 8, right? Because we know that they contain 8 different digits. There are 9 possible digits 1 through 9, and if the circles contain 8 different digits and they don't contain 9, they must contain 1 through 8. Okay, so essentially, as long as we show that there can't be a 9 in this bottom right circle, we've shown, since the 2 circles are the same sets of digits, that there can't be a 9 in either circle, and therefore the 2 circles are composed of the digits 1 through 8. Essentially, it's pretty easy actually to show that there can't be a 9 in the circle. Obviously, there can't be a 9 in this sort of grid cell here because there's already a 9 in that row. There can't be a 9 in any of these 3 cells here, there's already a 9 in that 3x3, and there can't be a 9 in any of these 2 cells because there's already a 9 in that 3x3, okay? So, therefore, the circles are made up of digits 1 through 8. Okay, which is going to be important for us to realize. Also, if we look at this sort of bottom right 3x3 and we consider the digit 7, then essentially by Sudoku we get that 7 has to be in this cell here because it can't be in this cell due to the row, and it can't be in these two cells due to the row, and it can't be in these 2 cells due to the 7 in this column. Okay, so there we go, we've unlocked the 7 there. And now, since we know that the digits in each of the circles are 1 through 8, if we consider where the 8 could go in this circle here, well, it can't go here or here because there's already 8 in that 3x3, and it can't go here or here because there's an 8 in that 3x3, so this cell here has to be an 8. Similarly, if we look in the top left circle, if we try and figure out where the 3 is in that circle, since we now know there has to be a 3, then obviously, these 2 cells can't, well, let's do it like this. These 2 cells here can't be a 3, there's already a 3 in that 3x3. This cell here can't be a 3 because there's already a 3 in that row. This cell here can't be a 3, there's already a 3 in that column. And this cell here cannot be a 3 because of the 3 in that column down here. So this cell here is therefore going to be a 3. Okay, and now if we look at where the 5 could go in the bottom right circle, well, these 2 cells can't be a 5 because of this 5. This cell here can't be a 5 because of this 5. And so there's only one circle cell left, which could be a 5, which is this one. And now if we look at where the 2 could go in the bottom right circle, well, none of these 2 cells could be a 2 because of the 2 in that row. So this cell here is a 2, which leaves us with 1 and 3 respectively in these 2 cells, 1 and 3. Okay, that is good. And we also have 1 and 3 respectively in these 2 cells here. And we can also now figure out where the 4 is in this 3x3 because of Sudoku. None of these 2 cells can be a 4, and we've already ascertained these 2 cells are 1 and 3. So this cell here has to be a 4, which is very nice. And that shows us then that essentially these 2 cells are going to be 5 and 7 in some order, except we know the order because there's already a 7 here. So this cell can't be a 7, which means it has to be a 5. And this cell here has to be a 7. Okay. And then if we look at this row, we realize, Okay, so the remaining 4 digits are 1, 2, 3, and 9, right? Because we already have 4, 5, 6, 7, and 8, so we're missing 1, 2, 3, and 9. In this specific cell, we can't have 2, 3, or 9. We can't have 2 or 9 because they're in the same 3 by 3, and we can't have 3 because it's in the same column. So we now know that this cell here has to be a 1, and that these 3 cells here have to be 2, 3, and 9 respectively in some order. 2, 3, and 9. Okay, and we also know because these 2 cells are 1 and 3, in this row, the other 2 cells have to be 7 and 8 in some order. So this is 7, 8. This is 7, 8. Okay. Now, given that these 3 cells here are 2, 3, and 9 in some order, that means that these 3 cells must be, what would it be? 1, 7, and 8, right? But we know that this cell here can't be 7 or 8 simply because there's already 7 and 8 in that column, and so therefore it must be a 1. So that cell there is a 1, which gives us the 1 in the diagonal, and then this cell has to be either 7 or 8. Okay, very good. And then if we look in that column, well, we're missing a 2. Oh wait, no, sorry. That's too early. If we look in that column, we know that this cell has to be a 3, because this cell can't be a 3 and this cell can't be a 3. So the only place a 3 could go in that column is in that cell there. So that's a 3, which means these 2 cells become 2 or 9. Okay, and then now we're still missing a 2, but this obviously can't be a 2 because there's a 2 in that row already. So it must be the case that this cell up here is a 2, and then this cell down here is a 9. Okay. Now, if we look at this bottom left 3 by 3, if we consider the digit number 1, we know that 1 has to go in either one of these 2 cells because there's 1s in the other 2 columns already. However, it can't go in this cell because we've already used up the 1 in the diagonal. So it has to go in this cell down here. Okay. We should be able to also almost... What else do we know? Well, we know that we're missing the digits. Okay, no, we know these 2 cells here are 1 and 3 respectively, and we're missing the 3 digits 1, 3, and 9 from this column, which tells us that this cell here has to be a 9. I think you might have been able to just get that from standard Sudoku as well, because of these 2 9s, once we discovered this was a 4, but anyway, there we go. So that cell there becomes a 9. We know that these 3 cells are 1, 2, and 3 respectively, because that's what's left in that column, 1, 2, and 3. So 1, 2, 3, 1, 2, 3, 1, 2, and 3. And so these 2 cells are going to be 5 and 8 in some order. 5 and 8, and 5 and 8. Okay. Okay, I'm trying to see if there's anything else we can do. Well, we immediately know, if we think about where the 7 could go along the diagonal, we know that obviously none of these cells here contain a 7 because we've already ruled that out for those individual cells. Like this is a 2 or a 9, this is a 5 or 8, this is a 1, 2, or 3. This cell here obviously also can't be a 7, and this cell here can't be a 7 because there's a 7 in those rows, which implies that this cell here is a 7, which gives us our 7 in the top left circle, because if we look at this cell, obviously that can't be a 7 because there's already 7 in the column. This cell can't be a 7 because there's 7 in that row. This cell and this cell cannot be 7 because there's 7 in the 3 by 3, so that only leaves this cell here to be a 7, which means this cell here is an 8 because it had to be a 7 or an 8. And that means this cell here is a 5 because that's the only remaining cell in that 3 by 3. This therefore has to be a 7. This has to be an 8. Okay. Cool. Okay. Now I'm trying to remember. Oh yeah, and we know that this cell here has to be a 1, simply because we already have a 2 and a 3 in that row, and it has to be a 1, 2, or a 3, so it has to be a 1. Which means that these other 2 cells have to be 2 or 3 respectively. In fact, we already knew they couldn't be 1 because of... Well, we already knew this cell couldn't be 1 because of the one in the diagonal, I guess. But, yeah, now we know for sure what's 1, so that's 1. And now if we look in the circle, we know that these 2 cells can't be 1 because obviously there's already a 1 in that 3 by 3, and this cell can't be 1 because the 1 in that row. So this cell here must be a 1. And then if we look at where the 2 could go in the circle, it obviously can't go in any of these positions because the 2 in that row. So there's going to be a 2 in this position here. Okay. There we go, and now we know that this cell here has to be a 3 because there's already a 1 and 2 in that row. So that becomes a 3, that becomes a 2. We know that this cell here is also going to be a 5 or an 8. Okay. So what are we missing? We have 1, 2, 4. Yeah, we still need a 5 in this circle, and obviously this can't be a 5 because the 5 in the column. So this cell here has to be a 5, which means this cell here is going to be an 8. This cell here is going to be a 5 because it has to be a 5 or an 8. Now it can't be an 8 by Sudoku, and this is going to be an 8 here. Okay. Nice. There we go. Now we are sort of in the final stages of this. What are we missing from the diagonal? Well, we are missing... Yeah, I mean, from the diagonal, none of these two cells could be a 2 because there's a 2 in both of those columns, which actually forces this cell here to be a 2, because if it's not a 2, then there can't be a 2 in the column, which sort of contradicts the rule of that column. So that has to be a 2, that has to be a 9. Then we can finish this column here by adding in a 2 down here and a 1 here. And then that makes this cell here a 3 by Sudoku, this cell here a 1 by Sudoku, this cell here a 3 by Sudoku, and this cell here a 1 by Sudoku. Okay, what are we missing? We are still missing a 3 in this column, but we have a 3 in this row, so this cell here can't be a 3, which means that has to be a 3, and this cell here has to be 9. We're missing a 7 in this row, but obviously we've already used the 7 in the circle, so this has to be 7, this has to be 8, this has to be 5 because that's the last digit in the top left, 3 by 3. Then if we look at this column, we have what? 1, 2, 3, 4. This cell here has to be a 5, I think. Yeah. And then if we look at the sort of diagonal, we're only missing a 9, so that has to be a 9. And then this has to be an 8 because of the column, that's the last thing left. And if we look at these two rows, we can just finish them off as usual. That gives us 3. And I think this has to be a 2. And boom. There we go. That is the percent Sudoku complete. I don't know if there's many sort of variants of Sudoku of this format. This might be one of the only variants ever released. It might be really niche. But it's definitely the case that there can be quite a few. I mean, at least I assume so. I assume that there are multiple sort of Sudoku-like grids with the added constraints of the sort of 2 circles containing the same 8 digits, that you could change what 8 digits those are, change the sort of initial digits that are given, and also rearrange the sort of digits 1 to 9 along the diagonal. And I'm sure that there's probably quite a few possible percent Sudokus that exist, like actual grids that are solvable. So I guess in theory, it's not like this is a unique sort of variant of Sudoku. There could in theory be quite a few Sudokus like this. But yeah, I mean, it's very interesting. I've obviously never seen this type of Sudoku before. Well, obviously, but I have never seen this type of Sudoku before. So it was fun to do. I did complete this on live, so thank you to the people that came onto the live. Let's just check. That's the sort of solution we got on the live. Okay, but yeah, I mean, without any further ado, that's that. That's the first puzzle. Out of like 3,000 and something types of puzzles that I have at the moment, probably will be more by the end of it if I ever do reach the end. But yeah, thank you guys for watching. See you guys in the next one. Goodbye.